Right, so this is what they gave you. They told you AW is parallel to SR. And they told you that ST is parallel to QW. Okay, so now you got a lot of triangles everywhere. Okay, so you got to focus on one thing at a time. They also told you that PQ over SQ. PQ over SQ is 7 over 2. That's the ratio. The ratio between them is 7 over 2. Okay? And then they said that W is the midpoint of PT. W is the midpoint of PR. It's the midpoint of PR. So that's all the information that you have. Okay? So the first question was, what is PT over TW? So PT over TW. So what you have to say is, well, if I look at PT over TW, it has to be the same as PS over SQ. Because of those two parallel lines from the proportional division theorem, we know that that part over that part must be the same as this part over this part because of those two parallel lines. So we first need to figure out what is PS. Okay, and then we can say PS over SQ is going to be the same as PT over TW. Okay, so what you can do is you can say, well, if I look at from there all the way to there, okay, that's what I have PQ, and SQ is just from there to there. Okay, so I'm going to say it's 7 over 2. Okay, but the reason why we put in the X is because we're not sure what the length is. If we just say it's 7 and 2, it's like we're saying it's 7 centimeters and 2 centimeters, but we're not sure that it's 7 and 2. The ratio is 7 over 2, which means it can be, X can be 2, for instance. Then 7 times 2 is 14, and 2 times 2 is 4. Then it can be 14 over 4. Or X can be 3. 7 times 3 is 21. 2 times 3 is 6. Then 21 over 6 is still the same ratio. So they told you the ratio is 7 over 2. But you're not sure what the distance is. So X is like a factor. So it can be any factor of that. Okay. It can even be 3,5 and 1. Any factor. So that's just a ratio. So now that you have this, now you can say, well, that means this part from here all the way to there must then be 5x. Okay. 5x and 2x gives you 7x. Okay. So that means that PT over TW must also be 5 over 2. 5 over 2 here, so 5 over 2 there. Okay, so we can say it's going to be 5 over 2. And then our reason is because ST is parallel to QW. And we use the proportionality theorem. Okay, so we use the proportionality theorem, and it's because ST is parallel to QW. So you can say both those things. Say which theorem you used, and then also say which sides are parallel. So that's how we found PT over TW. Okay. So now we need to find PT over TR. PT over TR. Okay. So we need to put in some values here. Okay. So let's say now, if it's 5 over 2, we can't say again the same thing. We can't just say it's 5 and 2. So we're going to call it this time 5y and 2y. To say it's the fact that the ratio is 5 over 2. 5 over 2. But we call it y now because again, we're not sure what the distance is. So the total for this is 7y, which means the total for this part will also be 7y. Okay, because W is the midpoint of PR. So if this part is 5y and 2y, then we can say this part is 7y. So then PT over TR. PT 5 over TR. 2 plus 7 is 9, so it's 5 over 9. So you can say this one is 5 over 9. And then again, it's the proportionality theorem. But this time, this time, we already had the values. We just had W is the midpoint of PR. So that's actually the only new thing we used, is the fact that W is the midpoint. So we used the 7y, and then we used the 7y there because of the midpoint. So actually, we can now just say M is the midpoint. W is the midpoint. W is midpoint. Okay, of PR. That's our reason for that one. Okay. Okay, so now to find PA over SQ. PA over SQ. So this part is 2x. Now this whole part is 5x. But A must be the midpoint of PX because W is the midpoint of PR. Okay? And these two lines are parallel. So we know that A must be the midpoint. So we can say that this part is 2,5x and this part 2,5x. Okay, so A is the midpoint. So we can say then that PA is 2,5 over QS 2. So we're going to say it's 2,5 over 2. 2,5 over 2. And then we can simplify that to 5 over 4. And our reason for saying this is because of the proportionality theorem. And then also because AW is parallel to SR. Okay, so that's how we find PA over SQ. So for QV over VW, QV over VW, you're going to look carefully here now which triangle to use. Okay, QV, VW is this line. And then if you look at this parallel line there and there, then it looks like we have to use QWA, that triangle. Okay, and then we can say QV over VW is equal to 2 over 2,5. Okay, so we're going to say 2 over 2,5, and that gives us 4 over 5. And the reason again is the proportionality theorem. And in this case, we used AW parallel to SV. AW parallel to SV. Those two lines are parallel, so this part over this part must be to that part over that part. Okay. Okay, so now it's given also that SR is 36, this part is 36. And then we must find AW equals 1. If you look carefully, remember W is the midpoint of PR and A is the midpoint of PS. And actually we also know that AW is parallel to SR. So we can say that AW will be 18 centimeters. Reason? Midpoint theorem. Okay, because of the midpoint theorem that says that the line parallel to the midpoint of the other lines is half the length of the base, SR. Okay, so it's a midpoint theorem, and AW is parallel to SR. Okay, that's what we know, that AW is parallel to SR. Okay. Okay, so now for VR. Now we need to find VR. Okay, now we know this whole part is 36. Okay, and we also know that this ratio is 7 over 2, which means VR over SV. If we want to find VR now, we can first say, well, if this is 7 and 2, we can say this part must be 7 over 2. Okay, so I think what we can do is you can for instance make it the 7Z and 2Z. Okay, because the ratio again is the same. 7Z, 2Z, 7Y, 2Y. But you can't call it Y again. Okay? But then the total for that will be 7Z plus 2Z is 9Z. And 9Z must be equal to the total, which is 36 centimeters. Okay? Which means you can say Z will be equal to 4. And therefore VR will be 7 times 4, which is going to be 28 centimeters. Okay, so that's one way of doing it.